Okay, so today we're going to be looking at how to remove a regional from the data. And so you can see a magnetic map of South Africa here, and this anomaly across the southern part is the BT magnetic anomaly. And so it's a very large anomaly, it's a regional anomaly, but this you could consider as a regional field you might want to remove from your data. And an example of this is the southeastern part here. Say, for example, I was investigating the magnetic features here, and I zoom in. And this line here is the BT magnetic anomaly, and these smaller circles are sills. And so the BT is a long wavelength anomaly. It's quite deep in the crust, deeper than at least 5 kilometers in the east here. And then these smaller circular sills are much shallower in the crust. Now, maybe less than, or definitely less than 5 kilometers. So they're high frequency anomalies. And so maybe I want to look at these sills and I don't want this background regional field as well. And so what I'm going to do is I'm actually going to extract a profile over this sill and over the BT anomaly, and we're going to look at what the profile looks like and then what it actually means to remove a regional. So I'm going to just create a new database here called test. On the right, I've got an existing one. And now I'm telling Geosoft I want to take a profile, so I go grid and image, utilities, grid profile. And here this, I choose for this version of my magnetic grid, and I'm just going to call it line 0, and I'm going to digitize from that. And click OK. So I'm literally going to take a north-south profile, so it says enter points on the profile, right-click when done. I'm going to click at the top of above the sill. I want to get a bit of the background field. I go over the sill and I go over the BT anomaly, and again I want to get a bit more of the background on this side, so I go down here and I right click and I go done. So you can see in this image background can kind of be considered green, so you've background here, red and blue is the BT, and you're going to green on this side. And so it's extracting this profile, and let's have a look what it looks like. You can see if you go under Windows, it shows you which windows are open. And here I've extracted X, Y, and this is the magnetic data. So I'm going to right click, show profile, and this is my magnetics. And so if I click on this profile, it will show me where I am on the map. So this anomaly here is the top of the sill, and that's all the way down past at the bottom of the BT. And this anomaly here, where is it? This is actually the bottom of the sill. So this is the southern part of the sill. This is the northern part of the sill. So you can see these smaller high frequency short wavelength anomalies are the sills, but this broad background, high and low, is the BT. And so we want to get rid of this high and low and just concentrate on these smaller anomalies. And so how you would do that is you would go database tools, because we're working with a database, filter, and we're going to use a high pass filter. So we click here. Your channel to filter is your magnetic data. Your output channel, I just call it filter, and then HP stands for high pass, and then 50 is this wavelength, so it's the cutoff wavelength. I want to start with 200 just to show you. As far as I understand, it's the wavelength of data, so the wavelengths longer than 200 are cut out from the data. As far as I understand, it's 200 meters because it's the units of your X and Y. I could be wrong. Let me know in the comment section if I am. Click on OK. You can see it adds this filtered column. I'm going to right click on the heading, show profile. And you can see it's starting to alter it and take out this broad regional. I'm actually going to right click on this feature here and go Y axis, same axis scale for all profiles, because I just want to now these values, it's the same values for both profiles. So this scale is right for both of these profiles. Whereas previously, you would see, let me put it back, sorry I'm not explaining very well. So it was here, and you can see when I click on this red heading, those are the axis values for the red. When I click on the green, they're slightly less for the green profile. So I want them to be the same for both. So that's why I click here, I go same axis scale, and then it puts it correctly. So now I want to, and you can see it's actually removed quite a bit of that broad regional. Let's go here again, and you can try several different values. I'm now going to try 100. Profile. Okay, 100's looking pretty good. We've lost a lot of the regional there. Database tools, filter, high pass, and last one, I'm just going to try 50 here. Show profile. Okay, so it's a bit, and so the main thing is we're taking out this broad high and low, and it's becoming flat. So we're just focusing on these anomalies now for the top of the sill, and this is for the bottom of the sill. So now I'm just going to take these off of here so we can see nicely. I would stick with the 50. And so this is a great thing to include in your report, because then the readers can actually understand what you removed. Whereas if you just say, I removed a regional, it's quite subjective. So still, what you're removing here, you can see it depends on what filter you're using. So a regional is a very subjective thing. That's why it's very good to record what you actually have removed. And so just, be very careful when removing a regional. It's not 100% set in stone what the actual regional is. So you are just making an educated guess. And so now I could actually import this into modeling software and model what the edges of the sill, how deep it is, what the dip is. You can also do this in Mag2DC if you've ever used the software. Mag2DC, developed by Gordon Cooper. You would go edit them, you would load in data, and you go edit the model and modify the regional field. You can actually remove a horizontal shift, like a DC shift, or a straight line from the data. And then I think you can actually remove an exponential as well. It's not always clear in here what you have removed, so that's why I like doing it in Geosoft, just so that you can have a record of what values you actually have removed from the data. So yeah, good luck with that.